This is the video lecture for the GPS mapping and its uses in environmental science lesson plan. It was created by John Bentz and edited and narrated by Sean Krupa. This video and accompanying lesson plan are part of Ohio University's Boat of Knowledge in the Science Classroom project, funded by the National Science Foundation. How would you describe the location of Southern High School? If you said that it was in Ohio, you'd be correct, and better yet, Southeast Ohio. And if we want to get really specific, we could say that it's located on Elm Street. But none of these are good enough to adequately describe the position of the high school. This is why we need map coordinates. Let's start with latitude and longitude. Latitude measures north and south of the equator. If you're above the equator, you're considered north, and if you're below the equator, you're considered south. Therefore, the equator is 0 degrees. Longitude measures east and west of the prime meridian. The prime meridian is 0 degrees of longitude. If you're left of the prime meridian, you're considered west, and if you're right of the prime meridian, you're considered east. Here's a map of the world with lines of longitude and latitude. Now let's talk about GPS. GPS stands for Global Positioning System. GPS answers the question, where am I? This is a universal way of describing location, and the system relies on 24 satellites orbiting the Earth. To accurately describe the position of one location, you need 4 satellites. One satellite handles longitude, another latitude, another elevation, and finally time. Here you can see the satellites in orbit of the Earth. At any one time, at least 8 satellites are visible. For more on the physics and technology behind GPS and satellites, it is encouraged to do the GPS and Mapping 2 lesson plan. Let's talk now about coordinate notation. The first number is degrees, the second is minutes, and finally seconds. This location is read as 38 degrees, 58 minutes, and 14.0 seconds north latitude. Similarly, the second location is read as 81 degrees, 54 minutes, 27.22 seconds west longitude. You might be asking why degrees, minutes, and seconds. This can best be understood by thinking of a clock. In a clock, there are 60 minutes in an hour and 60 seconds in a minute. In coordinate notation, there are 60 minutes in a degree and 60 seconds in a minute. Therefore, minutes and seconds are just subdivisions of degrees. You can think of GPS coordinates another way. Imagine drawing a line from the center of the Earth to a point on the surface. This point will have exact coordinates defined by longitude and latitude. Now let's talk about applications of GPS and map coordinates. The first of these are river miles. River miles are identical to the mile markers that we all see along the highway. Similarly, exit numbers associated with the mile marker also indicate the mile along the river which you are at. River miles typically begin at the mouth of the river. Here's a blown-up image of the Ohio River in southeast Ohio. Each location on the map is signified by a river mile and therefore a label. The next application is geocoding. The next application we'll look at is geocoding. Geocoding assigns GPS coordinates to a particular location so they can be found easily. Think about using Google Maps. If you want to look for a particular restaurant or store, that has a specific location. Sometimes it's not easily described by a street address, and therefore GPS coordinates might be more useful. Also, if you're traveling and you get live traffic updates, you can be notified of a traffic accident at a specific point along the road. This too is an application of geocoding. Another application is geocaching. Geocaching is a fun hobby where items or small rewards are hidden at a particular GPS coordinate. People who like to geocache have their own GPS units and go out for a hike where they look for the hidden items. Now let's cover how to read GPS units. Your GPS device may give you units in a few different formats. We see the degrees, minutes, seconds that we covered earlier, along with degrees and decimal minutes, and finally decimal degrees. For more information on the different forms of units and how to convert between them, it is encouraged to look at the GPS and Mapping 2 lesson plan. So, what else can be done with GPS? GPSs can be used to calculate distance between different coordinates. Let's talk about how to do that. As we said earlier, latitude lines run parallel. 1 degree of latitude equals 111 kilometers. How many miles would that be? Pause this video and take a few moments to work that out. Longitude lines converge near the poles of the Earth. Therefore, the distance between consecutive longitudinal lines do not stay constant. Therefore, we need to apply trigonometry. We can use the fact that 1 degree of longitude equals 111 kilometers times the cosine of the average latitude. Let's do an example. Here, the coordinates for a boat are given, and the coordinates for a dock are given. Let's calculate the distance between the 2 points. First, we start off by calculating the difference in latitude. If we take 39.81652 minus 38.11830, we get a difference in latitude of 1.69822 degrees. Similarly, the difference in longitude works out to 0.53562 degrees. Now, we start by calculating the distance for latitude. Hopefully you figured out that 111 kilometers is equal to 68.97 miles. Therefore, 1.69822 degrees times 68.97 miles per 1 degree of latitude works out to a distance of 117.13 miles. Next, we calculate the longitude distance. 1 degree of longitude equals 68.97 miles times the cosine of the average latitude. This can be obtained by taking our 2 latitude points and adding them together and then dividing by 2. This works out to 53.62 miles. Then we take 0.53562, which was our difference in longitude, multiplied by 53.62 miles, and we arrive at 28.72 miles. From this point, we use the Pythagorean theorem to find distance. As you can see on the right triangle, the hypotenuse is what we're looking to calculate. Therefore, c squared, which is the hypotenuse or distance we're looking for, is equal to a squared plus b squared. This is our distances for latitude and longitude. Squaring those distances and adding them together, and then taking the square root, gives us a distance of 120.6 miles. Now that we have the distance between the boat and the dock, what else can we do? If we're given the speed of the boat, we can measure how long it will take for the boat to reach the dock. By rearranging the equation for distance, which is just velocity multiplied by time, we can solve for time. Time equals the distance traveled divided by the velocity. In the previous slide, we worked out that the distance was 120.6 miles. If we divide that by 15 miles per hour, we get a time of 8.04 hours. Let's do another sample problem. This time you'll have to work the answers out on your own. Local residents have noticed that water entering the river near a protected fish hatchery was orange. The most likely culprit is an abandoned mine coming from a tributary near the river. This would mean a decreased pH level, which might be detrimental to the fish. The hatchery is downstream from the source of pollution. While looking at a map, scientists determined that the coordinates of the source are 39.11341 north and 81.76130 west. The fish hatchery is located at coordinates 38.97241 north and 82.09127 west. If the scientists know that the velocity of the river water never exceeds 7.5 feet per second, how long do the scientists have to correct the issue before it impacts the fish hatchery? Pause this video to work on this example problem. Press play when you're ready to view the solution. We start by finding the difference in latitude and longitude. The difference in latitude is equal to 0.141 degrees. The difference in longitude is equal to 0.330 degrees. Now we calculate the distance in latitude. We take 0.141 times 68.97 miles per 1 degree. At this point, it's also convenient to convert to feet since our velocity is given in feet per second. So we then multiply by 5,280 feet per mile. This gives us a distance of 51,347 feet. Next, we calculate the distance in longitude. First, we take 1 degree of longitude equals 68.97 miles and multiply it by the cosine of the average latitude. This works out to 68.97 times the cosine of 39.04291 degrees. This gives us a distance of 53.6 miles per 1 degree of longitude. We then take 0.330 degrees and multiply it by 53.6 miles per 1 degree of longitude, and again convert to feet by multiplying by 5,280 feet per 1 mile. This gives us a distance of 93,393 feet. Then we apply the Pythagorean theorem. Again, the hypotenuse is what we're looking for. We take our two distances and square them, and then add them together, and we arrive at 1.136 times 10 to the 10 feet squared. Taking the square root of this, we see that c is equal to 106,578 feet. To calculate the time, we again take distance and divide it by speed. 106,578 feet divided by 7.5 feet per second is 14,210 seconds. Since this many seconds is an awkward time, we convert these seconds into hours by multiplying 14,210 seconds by 1 hour per 3,600 seconds. This gives us a time of 3.95 hours. Therefore, the scientists have 3.95 hours to correct the mistake before the pollution reaches the fish hatchery. In summary, map coordinates are absolute and useful. GPS, or Global Positioning System, is a network of satellites that can pinpoint a location on the surface of the Earth. There are many uses for map coordinates and GPS. Remember, for more information on GPS and mapping, it is encouraged to view the GPS and Mapping 2 lesson plan by Sean Krupa and Blake Liberati. Thanks for your attention.